Right now, the sun is killing us. Not fast, not violently, slowly. Since before we existed, we built civilizations under its light. We called it a god. But gods don't protect, they consume. Every morning, 93 million miles away, a nuclear furnace burns 600 million tons of hydrogen per second. For all of human history, the sun meant life, crops, warmth, survival. We never questioned it. Scientists call it stable, reliable, middle-aged. The textbooks make it sound almost harmless, but the sun is not harmless. It is a 4.6 billion-year-old bomb. Earth has been in its blast radius always. And right now, at this exact moment, the fuse is getting shorter. It has always been getting shorter. Here is what the textbooks skip. The sun is not constant. It is getting brighter. Every 100 million years by 1%. 1% sounds like nothing. But we are not talking about a dimmer switch. We are talking about boiling a planet. When life first appeared on Earth, the sun was 30% dimmer. Life survived because the star was weaker. That sun is gone forever. The star you see today is already stronger than life on this planet evolved to handle, but we don't feel it. The timescales are too vast for any civilization to notice. That is the cruelest part of all. Think about what 1% per 100 million years actually means. In the time since dinosaurs vanished, the sun grew 0.6% brighter. That fraction of a percent was enough to shift global climates, alter ocean chemistry, and reshape which species could survive where. Now imagine that process continuing, accelerating in effect, century by century. The sun tightening its grip degree by degree. In approximately 1.1 billion years, solar output will increase enough to begin the irreversible sterilization of Earth's surface. The carbon cycle breaks first. Rising temperatures pull CO2 from the atmosphere faster than volcanoes can replace it. CO2 drops below 150 parts per million. That is the photosynthesis threshold. Below that number, plants cannot survive. Plants die. Then everything that eats plants dies. The food chain doesn't collapse slowly, it simply ends. 1 billion years, that sounds like forever, but it is only 7 times longer than all complex animal life has existed on Earth. Every species that will ever evolve on this planet fits inside that window. And the window is already closing, but the plants are just the first casualty. The real horror is what the sun does to the water. Water is not permanent. It is not a guarantee. It is a temporary accident of distance and temperature. And that accident is ending. As the sun brightens, surface temperatures climb. More water evaporates. More vapor floods into the atmosphere above us. Water vapor is a greenhouse gas. More vapor means more warming. More warming means more vapor. A loop with no exit. Scientists call it the moist greenhouse effect. A threshold beyond which Earth begins losing its oceans to space permanently. Not dramatically, not all at once. Molecule by molecule, year by year. The oceans don't boil, they just slowly disappear. Current models suggest this process begins in roughly 1 to 1.5 billion years. After that, there is no recovering the water, ever. Without oceans, the plate tectonics that recycle Earth's crust slow down. The volcanic activity that refreshes the atmosphere weakens. The magnetic field that shields us from solar radiation begins to fade. The atmosphere itself starts bleeding away into space. Layer by layer, everything that makes Earth habitable gets stripped away. Not by catastrophe, by the slow arithmetic of a brightening star. We have seen this exact story before, one planet over, and it did not end well. Venus was once thought to be similar to Earth. It may have had liquid oceans. Then its star did exactly what ours is doing now. Today, Venus is 465 degrees Celsius at the surface. Its oceans are gone. Its sky is sulfuric acid clouds. That is our preview. But even this is not the worst part. Because in 5 billion years, the sun stops being subtle. It stops being patient. It gets violent. In approximately 5 billion years, the sun exhausts the hydrogen in its core. It will not simply die. It will transform into something monstrous. Without fusion in the core, outward pressure collapses. Gravity wins instantly. The core implodes in a matter of seconds. The implosion generates catastrophic heat. It ignites hydrogen in a shell surrounding the core. The outer layers explode outward. The sun becomes a red giant. Its diameter expands 200 times. That distant point of light becomes a wall of fire filling our sky. Mercury disappears first, swallowed silently. Then Venus, consumed without ceremony. Then the expanding edge reaches Earth's orbit. But here is the detail that haunts planetary scientists. Earth may be gone before the sun even physically reaches it, not swallowed, evaporated, scoured to bare rock by radiation and solar wind, long before the expanding outer edge arrives. The oceans will already be gone, the atmosphere already stripped, just a glowing, airless rock falling into a wall of fire. And even the rock won't last. At temperatures exceeding 2000 degrees Celsius, silicate rock begins to vaporize. Earth dissolves, not with an explosion, not with a collision, just heat. Relentless, indifferent, patient heat from the star that once gave us life. But it gets stranger, because as the sun expands, something unexpected happens to the orbit of whatever remains of Earth. As the sun grows into a red giant, it loses mass through powerful stellar winds. Its gravitational grip on the planets weakens. Weaker gravity means wider orbits. Earth, if it survives, would spiral slowly outward, away from the expanding sun. This sounds like escape, but the expanding sun also creates drag, a thin envelope of gas and plasma that slows Earth's orbital velocity. Slower orbit means falling inward. These two forces, weakening gravity pushing out, atmospheric drag pulling in, create a race. And we don't know who wins. Some models say Earth escapes, barely. Others say Earth gets consumed. The honest answer is that current science cannot tell us with certainty, but both outcomes end identically. A dead, airless rock, orbiting the dimming remnant of the star that created everything we ever knew. Every city, every ocean, every fossil of every creature that ever crawled or swam or flew. Gone, as if none of it ever happened. And the sun will not notice. It never knew we were here. We were always just debris in its orbit. Temporary, unremarkable, forgotten. After the red giant phase ends, the sun's outer layers drift away into space as a glowing cloud, a planetary nebula, achingly beautiful. What remains at the center is the exposed core, a white dwarf, roughly the size of Earth, but containing the mass of the entire sun. A white dwarf generates no new energy. It only radiates residual heat from what it once was. Slowly, cooling over billions of years, over trillions of years, it fades, dimmer, colder, until it becomes a black dwarf, a dead ember in permanent darkness. The solar system will still technically exist. Surviving planets will still orbit, but they will orbit a dead star in absolute silence. No light, no warmth, no radiation, just frozen rocks circling a cold black remnant in the void. That is the final state of our home. Now step back, because the real horror is not the death of the sun. The real horror is the timeline we are already living inside. The sun is 4.6 billion years old. It has roughly 5 billion years left. We are almost exactly at the halfway point of its life. Humanity has existed for 300,000 years. In solar timescales, that is less than one heartbeat. We just arrived. The clock was already running. The first extinction event, plants dying from CO2 collapse, begins in 1 billion years. The countdown started before humans existed, and here is what that means. Every species, every civilization, every idea that will ever exist on Earth fits inside that closing window. The window is not closing fast, but it is closing. And the sun set the timer the moment the solar system was born. Carl Sagan said, "We are made of star stuff." He was right. But star stuff doesn't last. It burns, it expands, it dies, and it takes us with it. We are not just made of the sun, we are owned by it. It gave us everything, and one day it will take every last thing back. Some scientists believe humanity could survive by migrating to another star system entirely, a journey of 25 trillion miles. Serious proposals exist. Others suggest gradually engineering Earth's orbit outward using gravitational nudges from passing asteroids over millions of years. These are not science fiction, they are peer-reviewed proposals. We are a species that plans ahead when we choose to, but no civilization has ever survived 1 billion years. We don't know if survival at that timescale is even biologically possible. What we do know is this. Right now, today, the sun is still stable, the oceans are full, the sky above us is still blue. But stable is not the same as safe. Stable is just slow, and slow on long enough timescales is just another word for inevitable. The question is not whether the sun will kill us. Current models are unambiguous on that. The question is whether anything survives it. 1 billion years from now, if anything is still watching, the sky above Earth will be a different sky. Hotter, redder, closer. The last ocean will not end with a storm. It will end with silence. A slow evaporation into a sky that no longer holds clouds. The last living thing on this planet will not know it is the last. It will simply find the world is no longer the right temperature for living, and the sun will keep burning, indifferent, patient, already preparing its transformation, already moving toward the next phase of its slow death. We live inside a star's lifespan. We always have. We just forgot to check how much time was left on the clock. Somewhere in the universe right now, another star is doing this to another world. Another ocean is thinning. Another sky is reddening. We are not special in our fate. We are just another world that got lucky for a while, warmed by a fire that was always going to go out. Every sunrise you have ever seen, every warm afternoon, every ocean wave, all of it was borrowed from a star that is slowly calling in its debt. The most beautiful thing in our sky has been counting down since the day it was born. We just never had the instruments to hear it ticking. Look up at the sun tomorrow morning. That light left a dying star 8 minutes ago. It crossed 93 million miles just to reach your eyes. And when it touches your face, remember, you are feeling the warmth of something ancient, something violent, something that will outlast everything you love, but also something that, for this one brief moment in cosmic time, chose to give rather than take. And that is worth something. Maybe everything. The sun will kill us. Eventually, inevitably, but not today. Today it rises. Today it warms us. Today it is still, somehow, ours. What do you think will outlast the sun? What do you think is worth saving? Drop your answer below. This is worth talking about. Keep looking up, keep asking questions, and stay curious while the sky is still blue enough to look at.